Hello lovelies, in this video Mr. B is going to be looking at algebraic proof for your GCSE maths. Now initially this looks like a really scary topic, but it's not, because once you learn the rules you'll realise that there are very few questions they can actually ask you, because the same rules keep applied again and again and again. If you practice all of these, then you can see if you are exam ready by using the practice papers and the predictive papers that are over on my website.
At proof, I'm going to gradually build our way up to doing a full proof in the hard questions. So with the easy questions, the first concept is showing your working out. So for example, as a maths teacher, I can look at question, I've got 3x and x, they're going to multiply out to 3x squared. Then I can think, right, those plus 2's will be multiplied by the 1x and the 3x. So altogether, that's going to give me 3 times 2 is 6, and another 2 is going to give me 8x. And then I can look at the numbers, well, plus 2 and plus 2. That's going to give me plus 4 if I multiply them together. So I could kind of do some mental arithmetic in my head using my experience as someone who spent a lot of time doing questions like this. And you might be able to do these in your head as well. And that is the wrong answer. Now, it's not that what I've written is incorrect. It is actually the correct final answer, but it's getting 0 marks on an exam. And the reason is I haven't shown my working. And even worse, an exam might do something like, it might say that x plus 2 in a bracket with 3x plus 2 in a bracket is equal to, and the exam might actually even give you the answer. And in this situation, you have to ignore that the answer exists, pretend it's not there, and do the question yourself, showing every single step one at a time. So there's different ways that these can be asked, but essentially you have to show every single step of your working out. So what do you do? So for question 1, I'm going to write out the question, and I'm going to show the method I'm using to work this out. Now there's multiple methods, but the most common one, and you've seen this in previous videos with expanding brackets, is to multiply every term by every other term. You can use arrows to show this. So the first term in the first bracket will multiply both terms in the second bracket, and the second term in the first bracket will multiply both terms in the second bracket. Now, the key thing that the exam is looking for here in terms of showing you working is this will give you 4 answers. You'll have the x times 3x will give 3x squared, x times 2 will give 2x, 2 times 3x will give 6x, and 2 times 2 will give 4. So we need to see all 4 of those terms in the answer. And then for your final answer, you can combine the middle 2 terms like you normally would. So we've got the x squared terms. For the x terms, 2x plus 6x is 8x. And then we've got the whole number terms, the 4. And so what I've got here is the exact same answer that I worked out in my head, but I've shown my working. I've shown the method I'm using with the arrows, and then I've shown 4 answers, which then later on I'm combining. You just write the final answer, 3x squared plus 8x plus 4, you are going to get 0 marks if you've been asked to show your working. And again, the exam might even give you what the answer is. We're looking for the method, we're looking for the 4 individual terms. One thing you don't need to do is do things like, when we're adding together the 2x and the 6x, you don't need to write a separate line that says 2 plus 6 equals 8. Very basic bits of arithmetic don't need to be spelled out in detail, but we do need to see every single step of algebra calculations. So for question 2, again, write out the question, show the method that's been used, and then do your method. 2x times 2x is 4x squared. 2x times 7 is 14x. 4 times 2x is 8x. And 4 times 7 is 28. And again, those 4 terms need to be seen. Then you can combine the middle 2 terms. And you're showing this by writing out the answer. It's obvious, you can see the 14 and the 8, so therefore you would have a 22. What you don't need to do is write 14 plus 8 is 22. You don't need to write down basic arithmetic steps like that. Just showing the first line and the second line is enough to show what you've done. And there we have the final answer. Now for question 3, write down the question, show the method, and then do the method. X times 3x is 3x squared. X times 2 is 2x. Negative 2 times 3x is negative 6x, and negative 2 times a positive 2 is negative 4. And then collect up like terms for your final answer. And again, with the 2x take away 6x, giving negative 4x. The way you're showing that is not by writing an extra line of working out with 2 take away 6 equals negative 4. The way I've written it with the calculations going vertically down the page, you can see that the plus 2x and the minus 6x are right above the negative 4x. So it's really clear where they've come from. And if you just highlight this with this question, again, you can clearly see the middle part of this calculation becomes the middle part of this calculation. And what's staying the same? The 3x squared has remained the same, and the minus 4 has remained the same. So we are actually clearly showing our working out, and we don't need the highlighting either. Again, I'm just showing how the position on the page of the terms shows where the answer has come from. So you don't need to write an extra line of working out. Moving on to question 4, writing down the question, showing the method. Now, all these are expanding double brackets questions, but this could be with any sort of question. Again, it's just show every single step of your working out. We're using double brackets questions here because it's going to tie into the ones we're going to do for the medium and hard questions. So let's multiply out. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. 1 times 3x is 3x. And 1 times negative 5 is negative 5. Now I've shown all 4 terms. Now and only now can I then combine them. So we've got our x squared terms, we have our x terms, and we have our whole number terms. So again, don't just skip to the last step. Show the 4 separate terms. And then for the final question, write it down, show the method, and then use your method. X times 2x is 2x squared, and x times negative 6 is negative 6x. Negative 2 times 2x is negative 4x, and negative 2 times negative 6 is positive 12. Now, there's a few things that go wrong here. For example, someone might write negative 2 times negative 6 is negative 12 and get the sign wrong. But another thing that Showing Your Working does is its insurance policy that any question you do, if you do make that mistake and write negative 12, you're still going to get some of the marks. Even though the last answer's wrong, you'll lose marks for that. You'll get marks for the working out. So even though there are specific show your working questions where you have to show your working, you should be doing this for all questions. Now we have our 4 terms. I've collected up the x squared terms, then collected up the x terms. Negative 6, negative 4 is negative 10. And then we've got the whole number term, 12. And then we've got our final answer. Now, the next concept to look at for the medium questions is equivalence. And equivalence is, if you look at the questions carefully, they have triple kind of dashes in the equal sign. So it's not an equal sign, it's an equivalent sign. So looking at question 1, we have 8, x plus 1 in a bracket, plus 6, x plus 8 in a bracket, and it's equivalent to, with the 3 lines, 14, x plus 4 in a bracket. Now, in an equation, it would be equal with 2 dashes and would have a number at the end. And then we could use that number to solve the equation and get the value of x. Now, this is equivalence, and we've got x on kind of every single term. So we're not going to be able to find the value of x. What this is saying is that the 2 terms on the left-hand side can be rearranged to make the 1 term on the right-hand side. And with a method here, you're not allowed to use anything about the answer. So we're going to pretend the answer does not exist. And we have to try and get that answer using just the left-hand side. So we have some single brackets. It might be a good idea to expand those. So let's multiply the first bracket by 8. X times 8 and 1 times 8. Then with the second bracket, let's multiply the second bracket by 6. So 6 times x and 6 times 8. And then we can collect like terms. So 8x and 6x will give me 14x. And we can collect the single numbers. 8 plus 48 will give us 56. And if you're not sure about expanding single brackets or collecting like terms, go and watch the videos on those. So what I'm interested in here now is I got 14x plus 56, but I need to show that's equivalent to the 14 and the x plus 4 in a bracket. Now, looking at, I've got a 14 outside the bracket, and with where I'm up to, I've got a 14 in the question. So this is making me think, what if I take 14 out of both terms as a factor? So let's take out 14, and then we're going to divide 14x plus 56 by 14. So 14x divided by 14 is 1x, and 56 divided by 14 is 4. And now I've actually got the expression that was on the right-hand side, the 14 in the bracket with x plus 4. So I've shown step by step how you change from the left-hand side of the equivalence to the right-hand side of the equivalence, with the middle steps being expanding the brackets, collecting the like terms, and then factorising. And just like with the showing you working out, the important thing here when you're showing something is the layout. And we can clearly see that the 8 and the x plus 1 in the bracket has become 8x plus 8 because it's directly below it in the kind of sequence where I'm writing my algebra. And if you do this kind of vertical working out, working downwards, it's really clear where everything's come from. So moving on to question 2, you start off with one of the sides. So for example, the left-hand side here. And we need to finish with the right-hand side. So we can expand the brackets, multiply the first bracket by 6, multiply the second bracket by 6, because they've both got 6 on the outside. Collect like terms. 6x plus 6x is 12x. 36 plus 24 is 60. And then think about, now I've expanded everything, collected everything, how do I get to that right-hand side? Well, there's a 12 outside the bracket. I must be taking 12 out as a factor. 12x divided by 12 is 1x. 60 divided by 12 is 5. So I've started the left-hand side and I've ended with the right-hand side, and I've shown in between the process of how to get from one to the other. Now with question 3, we're going to start throwing in some negative numbers. So we've got 5 and x minus 2 plus 5 and x minus 8. And it's really important you do repeat this and write the left-hand side down again, because you're showing your starting point. So don't just start off with your second line of working. Always start off with repeating that part of the question. So we can multiply the brackets out by 5, multiply the first bracket by 5, and multiply the second bracket by 5. Collect like terms, 5x and 5x is 10x. Negative 10, take away another 40 is negative 50. And then we want to get to the right-hand side, which is a 10 outside the bracket. We must be taking 10 out as a factor. 10x divided by 10 is 1x, and 50 divided by 10 is 5. Again, I've started with the left-hand side. I finished with the right-hand side. Moving on to question 4. We have 6 and x plus 3. Take away, this will be important later, and then we've got 4 and x plus 7. So multiplying out the first bracket by 6 will give us 6x plus 18. But then when we multiply at the second bracket, we're not multiplying it by 4. We're multiplying it by negative 4. The sign always goes the number after it. Negative 4 times x is negative 4x, and negative 4 times 7 is negative 28. And really common mistake here for a lot of students to write a positive 28 there and kind of not connect that negative with the 4 and multiply both parts of the second bracket by a negative 4. Now we can collect like terms. 6x take away 4x is 2x, and 18 take away 28 is negative 10. So if we take out 2 as a factor, 2x divided by 2 is 1x, and 10 divided by 2 is 5. How do I know to take 2 out as a factor? Well, again, if you have a sneaky look at the answer, you can see there's 2 outside the bracket, so it's a good bet you'll be taking 2 out as a factor. You can look at the answer and use it to kind of give you a clue on where to go, but you can't use it as part of your calculation. And now looking at question 5, we have 6 and x minus 3. Take away 3 and x minus 7. So multiply the first bracket by 6, 6x minus 18. And again, be really careful here. We're multiplying the second bracket by negative 3. Negative 3 times x is negative 3x. And negative 3 times negative 7 will give us a positive 21, with a negative multiplied by a negative, cancelling out and giving us a positive. 6x take away 3x is 3x, and negative 18 plus 21 will give us 3. Looking at the answer, we have a 3 outside the bracket, so we're going to take 3 out as a factor. 3x divided by 3 is 1x, and 3 divided by 3 is 1, and we've arrived at the right-hand side. Again, we start at the left-hand side, we finish with the right-hand side, and we show all the steps in between. We don't need to write out things like, I'm expanding the bracket. It's obvious you've done that because of how it's laid out, with the expansion of the bracket directly underneath it. Again, we're collecting like terms. It's obvious you've done that because you collect the like terms directly underneath. So now we're going to look at proof and tie everything together. So we're going to prove that x plus 5 squared take away x plus 3 squared is divisible by 4. So first thing to do is to write out what we've been given. X plus 5 squared, x plus 3 squared. We're going to be showing our working out like the easy questions, showing every single step, because that's part of the proof, showing every single thing that you're doing. And like the medium questions, we're not going to be using the divisible by 4 as part of our working out. It should be something we find out on the very last step. Now again, we've got some brackets here, so it's a safe bet that we can expand these brackets. It might be helpful to get rid of the squared symbol and just write the bracket twice. And then we want to expand the brackets. So the x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. So I've expanded the first set of double brackets. And then we've got a table that's going to make things quite confusing. So a safe bet to do here now is say this is the first part that we've done. And we're going to take away the second part, which is the second bracket multiplied out. We have x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. We can combine like terms. So in the first bracket, 5x plus 5x is 10x. And for the second side, combine the 3x and 3x to give us 6x. Now, why have I contained the answers to the first and second set of brackets like this? Well, it's because of the negative sign. What the negative sign means is we're taking away every single term in that. So my first bracket is x squared plus 10x plus 25. I'm going to be taking away x squared, taking away the 6x, and taking away the 9. So I just kind of set it out like that just to help me deal with the negative numbers later on. So I wasn't doing 2 steps at once. So now collecting like terms, x squared take away x squared is 0. 10x take away 6x is 4x, and 25 take away 9 is 16. I know there's nothing else I can really do here to simplify. So now I'm going to have a look at the answer. I need to prove it's divisible by 4. So what can I see with my terms here that's something to do with 4? Well, 4x and 16, they're both in the 4 times table. And we can prove something is divisible by taking 4 out as a factor. So 4x divided by 4 is 1x. 16 divided by 4 is 4. And so if you can take out 4 as a factor like this, and everything's whole numbers, so you don't want any kind of decimal numbers or fractions, you've proven that our original expression, x plus 5 squared, take away x plus 3 squared, we've proven it's divisible by 4 because we could take 4 out as a factor. But of course, we had many steps in between of getting it into such a format where we could see that 4 is a factor. Because if you look at the original equation, nothing about that is telling you that 4 can come out as a factor. So we do have layers of expanding and simplifying brackets before we can get to that final conclusion. So let's try the same process with question 2. We have x plus 11 squared, and we're taking away x plus 5 squared. So let's expand the brackets, and again, write it out in full. Getting rid of the squared signs might help you, especially if you still want to draw the lines like we did in the easy questions between the brackets to show which ones you're multiplying. It's not needed to show proof, but it can help you to actually get the right answers. So in our first set of brackets, we have x times 11, 11 times x, and 11 times 11. Taking away the second set of brackets, x times x times 5, 5 times x, and 5 times 5. Let's collect like terms. 11 plus 11 is 22. And then collect like terms for the other bracket. 5 plus 5 is 10. Now for next space writing vertically, so I'm just going to nice and neatly come over to the other side. And I'm going to write out what I've got. So I've got x squared plus 22x plus 121. And then we have to remember the second bracket is being taken away. So it's going to be the negative version of everything inside. It's going to be negative x squared. It's going to be negative 10x. It's going to be negative 25. So now we can collect like terms again. X squared take away x squared is 0. 22x take away 10x is 12x. And 121 take away 25 is going to be 96. Now we've simplified as much as possible. Have a peek at the answer. We're proving it's divisible by 12. We need to be able to take 12 out as a factor to do that. So let's check we can do that and get whole numbers. 12x divided by 12 is 1x. And 96 divided by 12 is going to give us an 8. So because we have whole numbers in the bracket, we're showing we can take 12 out as a factor, and so it is divisible by 12. One last thing you might want to do is that if you can't write everything going vertically because there's not enough space on the page, you might as well put a little arrow leading on to the next part of the calculation so the examiner can follow the kind of chain of logic you've gone through to get to your proof. Just make sure it's nice and logical to the examiner where you're going from where. Moving on to question 3, write down the question. 3x plus 7 squared, take away 3x minus 7 squared, and that's going to be even. So let's show the full brackets to prepare for multiplying out. And to multiply out, 3x times 3x is going to give us 9x squared. 3x times 7 is going to give us 21x. 7 times 3x will give us another 21x, and 7 times 7 will give us 49. We're taking away from that the second set of brackets. So 3x times 3x is 9x squared. 3x times negative 7 will give us negative 21x, and negative 7 times 3x will give us another negative 21x. The negative 7 multiplied by negative 7 will give us a positive 49. Let's collect like terms. 21 plus 21 is 42, and negative 21 minus another negative 21 is going to give us negative 42x. So now let's do the takeaway. So we've got 9x squared plus 42x plus 49, and we're taking away everything in that second bracket. We're taking away the 9x squared. We're taking away a negative 42. That's a double negative, so it'll be a positive 42. And then we're taking away 49. So again, be very, very careful always with your double negatives. So then we've got 9x squared, take away 9x squared is 0. 42 plus 42 is 84x. And then 49 take away 49 is 0. So I've just got 84x. Now looking at the answer, I need to prove that this is even. That means I need to take 2 out as a factor. 84 divided by 2 is 42x. Now, even though 84x is simpler than 2 open bracket 42x, we need to show it in that form because that showing is proving that we can take 2 out as a factor to show it's divisible by 2 to show that it's even. And now we've finished our proof. Now, that question took up a lot of space, so let's clear this now and do question 4. So we have 8x plus 4 squared, take away 8x minus 4 squared. Now, at this point, normally in the videos, I'd be tempted to start skipping steps in the working out to get through questions more quickly. But when we're showing our working out, when we're proving things, we cannot do that. We need to show every single last step that we're making. Now, a step like this, when I'm just writing out the squared brackets as 2 single brackets, you don't necessarily need every single step like this, but you do want to go into as much detail as possible and show every single operation that you do. So just changing a squared sign into double bracket, I've not really done any maths there, so I don't really need to show this. But later on, when I'm kind of combining terms and actually expanding brackets, you do need to show every single last step without being tempted to skip things, even if you can do them in your head, because you're not proving it if it's stored in your head. It's got to be written on the page. So our first set of brackets, 8x times 8x is 64x squared, and 8x times 4 is going to give us 32x. 4 times 8x being the same thing. 4 times 4 is 16. Then we're going to take away the answer from the second bracket. Similar answer, 8x times 8x is going to give us 64x squared. 8x times 4, I know it's going to be 32, but the negative symbol this time will be negative 32x. And negative 4 times negative 4 will give us a positive 16. Let's combine like terms. 32 and 32 gives 64. And since these are so similar, we'll get that on the other side as well, but it'll be negative. We only have these patterns because both brackets have got the same numbers in them, except that one has a negative 4 rather than a positive 4, which changes the signs on some of the answers. Now let's get rid of the brackets. So I've got our first bracket. Because our second bracket has been taken away, it'll be a negative version of everything inside. A negative 64x squared, a negative 64x, double negative will make it positive, a negative positive 16. Positive and negative will make a negative. Collect like terms, take away 64x squared is 0. And you'll see that's happening every single time, but I'm not trying to skip a step that shows that because I need to kind of show every single thing that I'm doing. 64x and 64x will give us 128x, and 16 take away 16 will give us 0. I need to show it's divisible by 64. I need to be able to take out 64 as a factor. I need to get a whole number inside the bracket. 128 divided by 64 is 2. So I'm showing that I can divide by 64 because I've got a positive number inside the bracket. And now I've finished my proof. So now moving on to the last question. So we have 3x plus 9 squared minus 3x minus 9 squared. So again, we're going to follow the process. So we're going to multiply out our brackets. Let's write them as 2 brackets to help us visualize it. You can write all the little arrows if you want to, if that helps. So we have 3x times 3x is 9x squared. 3x times 9 is 27. And 9 times 3x will give us another 27x. And 9 times 9 is 81. Take away the second set of brackets. 3x times 3x is 9x squared. 3x times negative 9 will be negative 27x this time. And the same for negative 9 times 3x. And negative 9 times negative 9 is a positive 81. Let's collect like terms. 27 plus 27 is going to give us 54x. And the same on the other side, but negative. Then let's get rid of the brackets. So 9x squared plus 54x plus 81. We take away everything in the second bracket. Take away 9x squared. Take away the negative 54, which would make it positive because it's double negative. And take away the 81. The biggest mistake students are going to make here is not applying the negative to every single item in the second bracket. Commonly, it'll just be the first term will have a negative sign on, and then the other 2 terms will be as they are. Where we can see in my answer, the signs have flipped. Let's collect like terms. 9x squared, take away 9x squared is 0. 54 plus 54 is going to give us 108x. And 81, take away 81 is 0. So now look at the answer. I have to prove this is divisible by 18. So I need to be able to take 18 out as a factor. So we need 108 divided by 18 to give us a whole number. And you can use your calculator for this. 108 divided by 18 is 6. So it'll be 6x. So because we've got a whole number, we've shown that 18 is a factor. 18 is divisible. And again, with factorization and being divisible being pretty much the same thing.